So the first real question was, did you test the low-cost device from AlphaSense, Ian?
The short answer is no. There are many other devices that have come to market recently. This was a test program that started a couple of years ago, and we basically tested what was easily available at the time. And we know that there are quite a lot more of these devices now on the market, and we would love to test them in the future. And I encourage other people to test them too, but we did not test the specific device from AlphaSense, or indeed other devices that have come on the market since we started this test program.
Okay, so the answer is no, not yet at least.
Right.
Are any of devices time averaging their measurements over the sampling time interval?
I think that there's two parts to this. One is internally, what electronics have been built to actually sample from the sensor, and do they sample once a second, once every 10 seconds? Are they allowing for sensor time response? And unfortunately, I can't answer that very well, as these are tightly packaged, relatively proprietary devices. So the times that I gave on the slide that showed a summary of the monitors was basically how often they output their results. And it's likely that they are indeed doing time averaging of some sort, but the actual internal sampling frequency we don't know, because, again, that's proprietary. But in terms of a sampling time interval that you could use for control purposes, that will be based on what these devices are outputting rather than what is happening internally. So the ranges I gave range from something like you could record as fast as once a second with the AirBeam. The FooBot was averaging over 5 minutes. And probably from a controls perspective, we probably don't need 1 second time resolution for control purposes. Something like 1 minute would probably be fine. And unless we want to be controlling, filtration devices or ventilation systems on and off very, very rapidly, maybe the once every 5 minutes would be reasonable. But it seems like something like a minute would be a reasonable thing. We have to bear in mind that, of course, that there are other things about sampling times that would be involved here. Let's say you had one of these in your home or an office or what have you, is that there is mixing time in the space between the sources of the particles and you actually detecting it. That adds on another time scale that, of course, varies depending on the building size and the volume that you've got and how far away from the sources that you are. So I think we can make some sort of reasonable estimates of what would be a good sampling or averaging time. I think on the order of something like a minute. And basically, most of these devices would be adequate in terms of those sampling times. But unfortunately, I can't tell you exactly what's happening internally, as these are specific to the individual devices.
Okay, thank you. A lot of questions coming. So in Europe, we have for some time the net atmos device for PM2.5 CO2. Recently, the Philips AirVibe Sniffer B was introduced. Is there experience with the quality accuracy of the sensors?
Yeah, I suspect this question is going to come up a lot. And again, my answer will be the same as before. We simply tested what was available at the moment in time that we started the project. So yes, there are definitely other devices that we have not evaluated yet.
Okay.
So the answer is, I'm sorry, no. We have not looked at the Netatmo or the Sniffer B.
Okay. The other question is why to use particles for indoor quality monitoring? Isn't the source of the particle and the material of the particle important to understand if the particle does affect human health or not?
That's a very good question. One that would be a whole other conversation. But the short answer is that we don't actually know specifically what the chemical composition was of all the particles that we created, and specifically how they affect human health. The epidemiological data is kind of broadband particle related, but mostly it's combustion related, we think, because that's what it correlates with. But the health literature on this is pretty, how can I put it? They're as certain as they can be that PM 2.5 is very, very important. And it might, and different particles might introduce different reactions in people. But it seems like from the health and epidemiological data, we haven't found any studies where they found that the PM 2.5 was benign, for example, and didn't harm anybody. The magnitude of response obviously varies, but that's a very complex topic to get into with a lot of uncertainty. And so, and I'm not a medical expert by any means. So in our studies, we're just going with the literature on this, and it's simply due to particle size rather than composition, although there is certainly a bunch of research looking at the impacts of different particle composition, and potentially in the future, instead of just measuring the mass or the number of particles, we could disaggregate by their chemical composition. But until we have some solid health-based data that says, look for these specific particles, we really don't have the capacity to do that, nor do we have the lower cost monitors that would allow us to do that.
Okay, here we are, sorry. I noticed that the results are expressed in mass concentration. The sensor detects number of particles is a part of the difference of magnitude not due to the difference in the algorithm in the sensor or purpose to convert the number concentration to mass.
Yes, that is absolutely true. So they have the similar sensor in them, but they all have different calibrations that are trying to convert the sensor output that is just a counter into some sort of particle mass. And so they all have different calibrations and slightly different algorithms for interpreting the sensor output. And that question is a good one. Yes, they're all calibrated slightly differently. That's why they have these different responses.
Okay. How the results of this PM sensor influenced by variation in other indoor air quality parameters, such like temperature, humidity, or the pollutants? Sorry.
Right. We tested some pretty stable temperature and humidity levels. In other words, we did not exercise. We didn't have a test chamber to say exercise humidity from a low of say 5% to a high of 90% to see if that would have an effect. Temperature is an interesting one. These devices are self-heated internally, so it's possible that they could have some temperature sensitivity. On the other hand, if they're self-heating internally, maybe the temperature sensitivity would be low. We have not exercised these over high enough temperature range to see any calibration differences due to these parameters. But it's certainly a possibility. In theory, that could happen. Less likely to be humidity sensitive simply because of unless you had condensation inside the actual sensor chamber itself, and then the water droplets would be detected as particles, for want of a better word. But that seems unlikely given that these devices are heated. It's unlikely we have condensation from the point of view of humidity, but things like temperature could certainly have an impact. In terms of other pollutants, because these are visual devices, they're based on light scattering, these have to be pollutants that had some ability to scatter light, so probably not things like individual molecules in the air from VOCs, for example. So they're unlikely to be sensitive to other pollutants. But the temperature one's a distinct possibility that I think is going to be investigated in the future. And certainly if we come up with standardized test methods, things like varying the temperature over some reasonable range will be important. The people looking at outdoor air quality have certainly got some data on the temperature sensitivity of these devices because the temperature ranges for an outdoor sensor, of course, are much larger than the temperature range for an indoor sensor. So it could be that if we concentrate on indoor air quality, not outdoor, that we'll get a lucky break here because the temperature range is small and these devices won't be sensitive. But I think, honestly, that sensitivity remains to be seen at this point.
Okay, you have a lot of questions, Jan. How did you check the use of the local devices for control purposes?
We didn't actually physically ourselves connect them to anything, either using the onboard capability or writing some scripts to pull their data from the cloud. It's just a possibility, and we did not write any software to do that. So we have not actually controlled the device with them. I guess that would be the next step of evaluation here, is to put some of these devices in homes and actually use the control capability to control something and see if they're any good. We suspect that they'll work fine. The reason for that is most standalone devices that are used for particle filtration, I'm talking about devices for a home here, not something built into, say the heating, ventilating, and air conditioning system of a building, but it's a standalone device you can put in a room that has a good particle filter in it. They have basically the same sensor also. It's just hardwired to a fan control right inside the box itself. And we have done field studies of those standalone devices where they have their own sensor built in, and they work very well for particle control. They can be good at detecting particles, turning on at the right time, turning off when particle concentrations are low, and generally they do a very good job of keeping particle concentrations low in a room. But these are, standalone room-by-room devices. They're not part of a whole house system. But they're using the same light scattering, inexpensive sensors inside.
Okay. The WU target for PM 2.5 is 10 microgram per cubic meter. What is the accuracy of the sensors you have tested at this level?
Yeah, as I showed in the results, the sensors, I'll say the monitors, because it's not just the sensor, it's including the calibration also. And the answer is very different between the different devices, right? The sensors themselves are pretty good at PM 2.5, except for the particles below 0.3 microns, because their very nature of being light scattering devices means they really can't measure those very, very small particles. And so the accuracy depends on the calibration. Some are okay and some are not. So you'd have to refer back to my results. I showed which devices were okay. Things like the purple air, for example, is pretty good in terms of the magnitude of the signal compared with our reference devices. The spec, for example, not so much, but it's because it's biased towards larger particles rather than specifically PM 2.5.
Okay. You mentioned that an American team were working on the standardized test for air quality monitor. Can you provide any information about this?
Yes, this is being done by Newport Partners, who are building America team. And they're basically thinking along the lines of some ISO or ASTM test method where you would have specific, let's say, events generating particles of a known size distribution that you would measure with a reference device. And we would come up with a set of exposures to particles that would capture a broad range of events, similar to the ones I discussed earlier, and do what we had another question there about sensitivity to temperature and humidity, and so we come up with a suite of tests that encompassed a range of temperatures and humidities and different particle size distributions and magnitudes, so that let's say you came up with 20 different tests that you would run your device by, and each device would be run under all those same 20 test conditions, and it would allow us some sort of standardized approach to doing it. So this is probably going to require some sort of a test chamber approach where you can carefully control the ambient conditions and then introduce particles in some controlled way and include a reference device that you would compare to. Because we don't have, how can I put this? We don't have reference emitters for particles. Now, you can generate particles. There are specific particle generators that you could use experimentally for this, rather than, say, relying on shaking a dust mop or boiling a pot of water. And it's possible that we'd have to go to a more controlled approach for generating the particles, but that's the sort of thing that this research project is going to work on. They've only just started this research project, so we don't have any, we don't have an example set of the tests that we've run yet. But that's what's going on there, and hopefully that's enough information for now. Like I said, this activity has only just started, so I don't have a lot of information for you. I'm sorry.
Thank you. I think if you want to go to up to all questions, you will have, unfortunately, to short an answer because we have still, I think, 10 or so questions. Are you also planning to do some testing on CO2 sensors?
We are not planning to do testing of CO2 sensors. They've been tested quite a lot in the past, and some of my colleagues at LBL, for example, did a lot of work on CO2 sensors that were being used in commercial buildings for demand control. The key thing that we know for CO2 sensors is that historically the issue with them has been that they drift with time and need periodic recalibration. And they've got better in recent years, but that is still the case. But there are other people, I believe, still doing research in this area of can we make our CO2 sensors more reliable. Similarly, we'd have to do this with particle sensors also, right? If their output drifts with time or the calibrations change with time, like we found with CO2 sensors, they're going to need some sort of periodic recalibration. Our experience, at least in the US, in commercial buildings, is the periodic recalibration just doesn't happen very often, if at all, because it's not part of the building maintenance schedule. I mean, and this may be different in, you know, if you have a building where people are really on top of this, or in other countries where building operators are more aware of these issues. But certainly as we start using more and more sensors, whether it's for CO2 or particles, we're going to have to get in the habit, if you will, of periodically making sure they're still working.
Okay. Did you use a sensor in real-world environments, domestic, commercial? Is the placement of the sensor critical?
Sure. The second set of results here that I gave for in-home testing were done in one of my colleagues' homes, and it was just, you know, when they cooked something, they cooked it, right? So this was just, what if you put one of these in somebody's home and see what they are doing? Can we detect it? Admittedly, that's only one home, but, you know, we don't have an expectation this would change from home to home, other than, you know, if you never burn candles, then of course you wouldn't have that event to detect and so on. The question about the placement of sensors, is it critical? Depends on what you mean by critical. I think ideally you'd like the sensor to be in the room that you are in as the occupant and be either ventilating or filtering air in that room, rather than having the sensor in another room from you, because we could have the example of, let's say you're cooking, which we know produces a lot of particles. If you're in the kitchen, I think that you want that kitchen to get ventilated and the particle concentration gets high. But if you're in the living room, you know, maybe not so much, and vice versa. If the detector's in the living room, it won't help the person in the kitchen. Except eventually, you know, there's a time delay as air mixes in a home. So generally speaking, you could say it's sensitive. I don't know whether you would say it was critical. If we're talking about operating a whole house filtration or ventilation system, you might need to have a little bit of mixing, but maybe if you have a ventilation system, you're already effectively moving air through the house and doing some mixing anyway. I'm sorry I'm giving a very vague answer to this. It's because it depends on how critical we feel critical means, right? If you must detect every event instantaneously, you're going to need a sensor in every room. But is that really what we need to do in order to protect the occupants from a long-term chronic health exposure perspective? The answer is probably no. So, you know, maybe you might have a couple of sensors in a home if you wanted to do this, or in an office space, if it's a large open plan office, you might have more than one or two, and you can think about maybe critical locations. Because we know that we get a lot of particles from cooking, probably one would be the kitchen. And the other sources of particles are, you know, generally people's activities while they're awake and so on. So maybe another sensor in the living space if you wanted to go to a multiple sensor approach. That probably seems like a good idea, particularly in a larger home or larger office space.